In this video we're going to talk about equivalent fractions, and before we do that we have to know what equivalent fractions are. So equivalent fractions are when any two fractions are equal, and what we can do is we can change a fraction by dividing or multiplying by the same number. And what happens is the fraction looks different, but the actual value doesn't change. So the value of the fraction doesn't change if we multiply and divide the numerator and denominator by the same thing. It can be a number or it can be an expression. And that's all fine as long as that number is not 0, because of course we can't divide by 0. So if we have a fraction, for example, and we multiply, like in this case, the numerator and denominator by x squared over x squared, we get an equivalent fraction, because really x squared over x squared is simply 1. And we talked about this actually when we did converting units, because we were multiplying by 1 to change the unit without changing the value. To reduce a fraction to lowest terms, which is what we're always going to be doing, means to take away all the common factors. So if we have 8 over 4, we need to divide top and bottom by 4 because 4 is a common factor between them. We have to remove all possible common factors except for -1 and 1, because those aren't really going to change our answer. So to reduce to lowest terms, we divide both the numerator and denominator by all factors that are common. So we're going to try some examples then. The first example here, we're going to focus on no addition subtraction. We're going to look at what happens to those in a second, but here we have 16 and 24. So we can divide 16 by 8, which means we have to divide 24 by 8. So 16 divided by 8 leaves 2. 24 divided by 8 leaves 3. So we did that by dividing top and bottom by 8. Now we look at the top has an A and the bottom has an A, so we can divide the top and bottom by A. And what happens really is those cancel, and so those are gone. We have b cubed on top and b squared on bottom. So we can divide top by b squared, it just leaves b, and bottom it just leaves 1. C squared and c5, we can divide this by c squared and it's gone, it leaves 1, and the bottom leaves c cubed. So we end up with 2b over 3c cubed. And we've actually done this example before when we were talking about exponents. So we have a note here that says you can cancel factors. So remember, factors means we're multiplying, but not terms. So if something is added or subtracted, you can't cancel it. And that's what we see in this example down here. We have x plus 2 on top. We're not allowed to do anything with this x here because it's added to something else. It's a term, so it has to be left alone. This other example here, this x is a factor because it's multiplied by the bracket. So in this one, it's okay to cancel. So things that are multiplied, we can cancel. Added or subtracted, can't cancel. So we're going to go ahead and look at example 14 then, and see some places where we can do this. So if we take this, the first thing we're going to do with all these examples is factor if you can. So we have x squared, x minus 2. The denominator, we have a difference of squares. So that's x minus 2 and x plus 2. Notice the brackets here are factors because they're multiplied together, so we can cancel this x minus 2 factor with this x minus 2 factor, and we're left with x squared over x plus 2. In the next example, 2 and 2 can cancel, a and a can cancel, and you're left with 1 over x. Keep in mind, when you cancel something, or you divide 2 by 2, you get 1, not 0. So when you cancel it, it leaves a 1. This next example, the answer is, well, exactly the same as the question. And that's because the denominator is has two terms. The 2a and 2a cannot cancel. So we're not allowed to do that because this is 2a plus x. This 2a is a term of the whole denominator. So we have to leave it alone, so the answer is already in lowest terms. We're going to stop that video there. We're going to save the factors that differ in sign for the next video, because there's a bunch more examples there. Make sure you have an idea of what we did there. Go ahead and try the next examples if you can. So we'll see you in the next lesson.